Hello and welcome to part 3 of our AI series. In this series, we're going to be expanding on our AI to make it go from an AI that just goes from a waypoints, like the one we've done in our last two videos, and we're going to transition that into an AI that can call its friends, as well as organize around the player, much like if you have a bunch of enemies that need to attack the player. So just like last time, we have our AI set up. The AI navigates between 4 different points. But if the player gets close enough to the AI will start to chase the player. Now, previously, we could have multiples of this AI, but all that happens is they work individually. If it walks within a certain range of a single AI, that AI will start chasing until you move out of range, at which point it goes back to its patrol method and continues on. Well, we want to change that to make it so when we walk in range of a single AI, it lets all of its AI friends know to come attack as well. So we'll hop right into that. Right after I say, if this video does end up helping you, please like, comment, subscribe, all that jazz. It really does help us a lot. And we'll hop right into it. The first thing we want to do is I've made a totally brand new script called New Patrolling. It is going to be an exact copy of our patrolling script. Only this one will be called New Patrolling just because I will at the end of all of these post the code and I want to keep them separate so we have a copy of each. Our patrolling script has our old code in it. We're just going to copy that. Our new patrolling script has nothing in it. So I'm just going to delete everything, paste this, and then right up here where it says patrolling, we're just going to swap this to new patrolling because the class we are making is the new patrolling C# class. Now, as this is getting a little bit more complex into AI, I will have to go a little bit faster with this code, so I won't explain absolutely everything, but I will do my best to fill in any of the gaps. The first thing that we're going to do is we're going to create another serialized field, just like last time. The serialized field is going to let us put an array, and that array is going to be an array of where we store our fellow AI. We're going to make a private array of all of this class that we're storing, so it's going to be called a private new patrolling array, and we're just going to store all the different AI that also have this individual class, and we're going to call this fellow AI. And all that's going to do is it's going to come here into our editor in any place where we have this new AI script. So let me just duplicate this, and we're going to call this AI group 1. We're going to deactivate the original AI. We're going to look at this AI group 1, and instead of having the patrolling script on it, we're going to add the component that is the new patrolling script. And in this one, we have some of the old things that we need to place onto the player. But if we come to our script and save it, we will now have a new array that shows fellow AI. So we can create this and size it however we want, but we'll be able to store all the other AI that are in the scene. Just like before, we can store our waypoints here. So we can just click and drag our waypoints so we go in order from 1 to 2 to 3 to 4. Our agent is this individual agent. The player, we just click and drag our player. And then our new array elements of fellow AI we haven't created yet, but we'll get to that in a little bit. But I just wanted to show that it pops up here. So we have this array of our fellow AI, and what we need to do is create a function, and if that function is called, we want to make all of our AI, all the fellow AI that we've collected into that array, also attack. So let's go ahead and make that first function. And this won't work right away. We'll need to make a few adjustments to the code, but we can make the function before we start messing around with the code. So let's call this attack player. And when this function's called, we need the AI to attack the player. But we need a way to target all of these AI and tell them the new code. So we're going to do a for each loop for that. And the for each loop is really neat because I don't have to specify the length or anything like that. I can just say for each of the new patrolling classes that are in this array, we'll say for each new patrolling called in this array, so in fellow AI, so for all of the new patrolling objects in this array, we're going to execute some code that's not packages, it's just Me hitting the wrong button, apparently. All of this is going to execute one code, some set of code. Well, what do we want it to do? We want it to change the destination of every agent's position to the player's position from the waypoint where it was previously having. So what we want to do is we want to say the agent of new patrolling in.agent.destination, not desired velocity, .destination. So the destination of that new agent, we're going to set that equal to the player.transform.position, because that gives us a vector 3 for the agent to travel to. So if we do that, it sets all of our AI to go to the player. The only issue is if we come up here to our update function, we know that as soon as the next frame goes, it'll say, am I within 10? No. Well, we need to go to our current waypoint. So what we need to do is create a Boolean just as a way to tell it, like, hey, we're not following the waypoint system right now. We need to go attack the player because someone has seen the player. So we need to come up here to our update, and we're going to put all of this within an if statement, and it's going to be attached to a Boolean. So we need to make that Boolean, and we're going to put all of this within an if statement. So we're going to say up here where we have this current end thing, we're just also going to create a Boolean, and I'm going to make this public, and I'll explain why later. But this Boolean is going to be a public bool called patrolling, and it's just going to be, am I patrolling or not? And since we made a public variable right there, we need to instantiate it in our start. So patrolling is equal to true. So initially when the game starts, all of the AI should be patrolling. And what that's going to allow us to do is to come here in our update and say if patrolling, execute some form of code. And the code we want to do is all of the code that we had previously done for our patrolling AI. That's great. Now we need a way to get from this code, when it sees the thing, to turn to the group swarm the player. Well, we sort of already have that right here where we have this distance where we check to say, hey, are we less than 10? Oh, we are? Well, the first thing we want to do is actually call all of the other players. So we'll call this function where we've already done some of the code to say, go attack that player. So if a AI ever gets to this point, it says, hey, all of you AIs, all you fellow AIs, come attack the player with me. It sets the speed and the destination, and they all go charging after the player. It sets the player. But we also need to make sure that when we come down here to our attack player, we need to set all of our AI to be not patrolling. So the first thing that we need to do in this attack player is for each of these new patrolling, we need to say n dot, and this is why we made it a public variable, because we want to access it here. We want to say n dot patrolling is equal to false. They're no longer patrolling, so none of this code right here, all of this will not execute. It will just attack the player and go to the player's transformation. And if that's all you need, great, we're essentially done. But for the most part, we need to be able to swap in and out of these systems, right? We don't want to chase the player constantly. If the player manages to evade the AI, well, we don't chase them because we don't know where they are. We need to be able to swap back to this waypoint system and do so seamlessly. Now, this is a little more challenging. We don't need to know whether this individual AI is within 10 meters. We need to know if any AI in the entire group of AI is within 10 meters. This can be a little tricky, but we can create a function that does this for us. So we're going to create a public bool function. So in this bool function, we're just going to check the distance of every AI. So we'll call this check distance. So since it's a bool function right here, so a public bool function, we need to return true or false. There's a couple ways that we need to return true or false. We need to return true, meaning that if we're within a certain distance, we're returning true. And if we're not within a certain distance, for everyone in the array, then we return false. So what we want to do here is go through our array. And we can't use the for each one for this one, so we just need to do a regular for loop. So we'll say for int I is equal to 0. We're starting out with I as 0. And we say I is less than the fellow AI dot length. This is going to allow us to change the length of that AI array and not have to change our code at all. And then we're going to give this an I++. So inside this for loop, we'll iterate through for the exact number of AI in the fellow AI array. We're going to say, we already actually have this code. What is the distance between this AI and the player's transform.position? So we'll say if we're inside this distance, what happens? So if we're within 10 of the player, we need to keep following, right? So we're going to return true. Yes, we checked our distance, we're within, return true. We're good there. If we go through and any of the AI in this trigger that, we're returning true. But that's not quite what this says. We need to edit this just a little bit because it says this.transform. That refers to the AI controlling this script. We need to actually change this just a little bit to be the AI that we're iterating through with this function. So we'll just say fellow AI, and then we're going to give it the index of I since we're iterating through on this for loop. So index position I, that position. So whatever AI you are, whether you're the first one or the fifth one, what's the distance between you and the player, and is that less than 10? If it is less than 10, return true, yep, we're still within chasing range, so we're all still chasing the player. If that's not true, so we get all the way through this loop and we don't find anything, well, then and only then do we return false. So none of the AI are within range of the player, so all of the AI should go back to following our waypoint system. So we need to just get that code to finish up here in the update. So we have what happens if we're patrolling. We need to have what happens if we're not patrolling. So if we are not patrolling, meaning that we're attacking the AI, well, what do we want to have happen? So all we need to do each frame is just check to see, are we within range of the player? If so, then we keep attacking. We keep setting the destination to the player's new position, which is presumably the player's moving. And if not, we need to set patrolling to true, so we come back to this waypoint thing. So we'll go through this. So since we made a Boolean function down here, we can call this Boolean in an if statement. So we'll just say, if we check the distance, run through that array, and if it returns true, meaning that at least one of the AI is within 10 units of the player, well, then we call attack player and restart the whole cycle for this frame and just say, hey, wherever the player moved, that's where we're all moving again. And if it's not true, the else here, if it's not true, what do we need to do? We need to set patrolling equal to true. So we checked. None of them are within distance of the player for this frame. All of the AI go back to patrolling. We come back up here and it says, hey, are you within 10 units? No. Well, just keep iterating through your waypoints and your patrol. So really quickly, with these couple new functions, we'll edit these further in a bit, but for right now, the basic code that we've added has allowed all of our AI to work together. When one of the AI spots the player, all of the AI spot the player, because each of the AI will be calling this script. So I say we go test it out. Let's see if all this rambling that I've done ends up working. So we have our AI group 1. Obviously, we need to make a few of these, so I'm going to duplicate 3 of them so we have 3 to test. So AI group 2, AI group 3, and just really quickly on these, I'm going to change some of the waypoints so that the waypoint patrolling is just a little bit different. So this one, we'll go from waypoint 1 to 2 to 1 to 2 and just sort of bounce back and forth here. The second one we'll go through in reverse order. So 4 to 3 to 2 to 1. I think I put those in the wrong order. 4 to 3 to 2 to 1. So now all the different AI will be patrolling in a different location. They'll all have different waypoints, but we do need to come and do one quick thing to all 3 AI. We need to set each of our AI group to have all of the fellow AI. So we're just going to click and drag on each of them, AI group 1, AI group 2, AI group 3. So now all of our AI have all the other fellow AIs. So we'll go ahead and hit play. And if we come to scene, we'll see that they all patrol just like we thought they would. We'll move the player out. So just like before, they all have a similar patrolling AI. It works just like the last one. But watch what happens when we move within 10 units of the player. You see all three of these AI are now chasing this player. And I know this because if we come here and we look at this new patrolling script, we see that this Boolean for patrolling is false. All three of them are only attacking the player. And if we go to the next frame, they're still only attacking the player. But watch what happens when we move the player out of grip. So we haven't iterated to the next frame yet. They're all still not patrolling. They're attacking the last known position of the player, which is here. If we iterate to the next frame, it goes through and does all the calculations again, and it says, hey, none of us are within 10 units of these AI. So if we look at all three of them, all of them have patrolling checked. They're back into patrolling. So if I unpause, go back to our scene, we'll see that they're all patrolling normally, come in range. They all start attacking the player. They're all going right around through it, which will be what we fix next. But for right now, they're all attacking the player. I move more than 10 distance away. They all start patrolling much like they normally would. So that's great. We've solved one of our problems, but we've not solved all of our problems. Because right now, if we come here and we look at our player and they all come attack, they all come run and bump into each other and all sorts of things. And that's okay, but it's not perfect, and especially considering there are some pretty decent workarounds to making this happen that make it a little bit more fluid and give the player a little bit more room to run. Imagine all of these had rigid bodies and the player was trying to move. All of the AI would be stopping the player from moving, and that's not a fun game, and ultimately what we want to make is a game that is fun for our players. So how do we set this up so that the player can move, but the AI are still attacking the player, but sort of appear like they're in attack range, but aren't quite on top of the player? We're not going to the exact position of the player. We're not bumping into each other. We want to flock to them, but stay separated. There's a few ways you can do it. There's a lot of really fancy coding to do it with AI, but there's also a really, really simple way to do it. And I think if you pay attention in a lot of games, you'll notice that this is one of the ways that I do it. So off camera, before this episode, I made 3 different spots in relation to our player. These are just empty game objects as a child of the player. And we'll see we have chase 1, 2, and 3, which are just 3 spots around the player. So again, chase 1 is down here, chase 2 is off to the right, chase 3 is off to the left. It's 3 different spots for our 3 chasing AI. So what if our AI went to a spot right next to the player? And if when they got to that spot, they played in a sword attack animation or something like that. That's sort of the behavior you expect to see. Lately, I've been playing some Sea of Thieves. So when I run into a skeleton, I want the skeleton to run up to me, sort of, right? Like right next to me, and then play an attack animation so I can engage in combat with the skeleton. So what we actually want is for our AI to get to a certain distance away from the player. And I think in a lot of AAA games, they'll either have complicated coding or a very complex system of this. They'll have like 8 slots around the player for melee attacks, and then further out they'll have like 16 slots for range attacks. So, there's lots of positions for the player, for the enemies to go to, and make it feel like a dynamic system that's evolving through the game. After all, what we said in episode 1 was that we want our AI to seem like it's smarter than it is. We want to fool the player into thinking, this AI is pretty decent, it knows what it's doing, even though we're not really doing all that much complicated code. So how do we do that? Well, I'm going to assume that you have a character controller, a player controller, something of that nature, and we're going to add some things to that. And we're also going to add some things to our new patrolling AI and update a little bit of what we've been implementing so far. So the first thing we want to do is we're going to go over our player controller. Presumably you'll be adding this to a working player controller script. So if you have a character controller, player controller, whatever it is that you have working, we just need to add some things to our start function and we'll be good to go. So what we want to do is create a public array of booleans for the spots because we want our spots to be known if they're full or not. So for each of the spots around our character, our chase 1, 2, and 3, we need to know if those spots are full. If the AI goes to the character and says, I'm attacking you, which spots are available? That's essentially what we're asking with our code. And the way we can do that is just having an array of those booleans. So we're going to make a public array of the bool type, and we're just going to call this spots. So we have 3 spots. Which ones are open? That's what we need to ask. So, well, that's code. So on our start function, we need to do some form of code that sets our spots to, there's nothing in them at the start of the game. And we're just going to actually make a separate function, but we're going to call that function in start. So let's make this function a public function so we can call it from other scripts. And we're just going to call this empty spots. And in this function, all we're going to do, those are not the right keys. And in this function, all we're going to do is we're just going to iterate through our spots here. So similar to before, for int I is equal to 0, we're going to do some form of code. I is less than spots dot length. So no matter how many spots you add around the player, we don't have to change our for loop. This works a lot if I put the right syntax. So we just need to say for all of the spots in our array, we want spots index I to be false. There's nothing in this spot yet, right at the start. So we're going to call that at start. So at the start of the scene, it says, hey, on my character controller, on this player, I have all these spots for attacking AI when the AI want to attack me. None of these are filled at the start of the game. That's all this code does. And it sets it up so we can call this class empty spots from our patrolling AI class because this is public. If this is public and this is public, we'll be able to access this from our new patrolling script. If they're not public, we won't be able to access them. So go ahead and leave those public and we'll come over here and we'll make the necessary edits. The only thing we really need to add to our variables is we need to get an array, obviously, of these chasing spots and show that to our AI. So much like before with our other arrays, we're going to create a serialized field of a private array of game objects. And these game objects, we're just going to call these our chase spots. And additionally, what we want to be able to do, since we made these, I did not mean to click that. Since we made this function public here and a public boolean referring to this array, we want to be able to reference that in our code. So we're going to go ahead and make a public player controller call. If you have a character controller script and not a player controller script, it just needs to be a character controller. We just want to make a public reference to that player controller or character controller. All this is doing is saying, hey, I just want to know, I want access to this script, essentially. And we want to be able to get it in this script. So we don't actually need to change pretty much any of this. The only things we need to change are our attack player and our check distance functions here. Because these are the functions that control when we're attacking the player. These are the areas that we need to deal with the positions around the player. So this is going to get a little more complicated on the inside here, but we need to just make sure that we have a way to iterate through the number of potential filling spots here. So we're just going to create a variable. It can be a var or an int. Yeah, we'll keep it int just to make it safe and simple. So we're just going to call this int k, then we're going to set it to equal to the start. So each time we call this, int k is set to 0, and then we'll go through and iterate every frame when we're attacking the player. So what we're going to do is we're actually going to comment out this line of code because that is going to change. We are still setting our patrolling to false, but this time, instead of our in.agent destination being set to the player, well, we want to set our destination to those chase spots, right? We want to go up to the player, but not exactly to the player. and go to our specified spot and then play our attack animation or whatever we want to do once we get there. So we actually need to set this to our chase spot. So we made an array up before of the chase spots, and we need to give this an index, right? We want to iterate through these chase spots so we don't ever go over them. So we're going to give this an index of k. So remember, we had our spot before. Each time we call attack player, it sets their index to k. And specifically for that, we actually need to grab the transform and the position of that empty game object. And then the last thing we need to do is iterate back, right? We're going through all of our AI, so we need to iterate again. So we just do a k++. So now as this for each loop goes through, it goes and sets the next agent to index 1, then to index 2, then to index 3. That way we go and fill up a circle around the player if we have it set up that way. But we also need to just to be sure, this isn't strictly necessary, but just to be sure, we want to have a way to make sure we don't have an out of bounds here. So just in case we ever run into a situation and we can go out of bounds, we'll say if k is greater than or equal to the length of our chase spots. So if we have more AI than we have chase spots, and we need to grab the length of that, right? Because that's going to give us the number of chase spots. So if we have more AI than we have chase spots, then we just start looping through again. We'll say you go to the first spot, and then k++ goes again. So all that does is say we have 6 AI and we have 5 chase spots. The 6th AI will then go to the first spot again, index 0 in the array, and that index will have 2 AI vying for 1 space. It's not a perfect system, but it is kind of a pretty decent one because we're not trying to do anything super complicated like distance measuring between all the different AI and communicating in a network, and that's just a little bit more than we actually need to do for this. The other thing that we need to do is, before we made this Boolean of empty spots to know whether or not our spots are filled by an AI that's attacking, well, if we finish up our check, right, so we're back down here in this check distance one. If we go through all of these and we find that, you know, the player is not within range of any of our AI and we're returning false, we also want to make sure that all of our AI are set back to not patrolling, right? We're returning false, so we're going to come back to patrolling, so they'll no longer have this destination. But just in case we want to reference these spots to see if they're full or not, we need to make sure that we call the player controller and say, we want you to empty the spots. And we can begin anew if the player ever runs into the AI again. So if we come to our scene now, and we have our player, we know that there are 3, we can even change this to 4 so we can see it in action. We have 4 spots that the player could potentially be running into and filling. And all in our AI, we now don't have the player controller, so for all of our AI, I'm just going to grab these and drag the player controller on. And we need to set our chase spots. So we know that we have 3 chase spots, so I'm just going to drag these in order to chase 1, chase 2, and chase 3. So again, these chase spots are directly behind, to the right, and to the left of the player. Another thing I want to do for this one, I'll hit play and then we'll fiddle with these. So if we come to our scene view here, we see that all of our AI are patrolling. As soon as we come here and we're within range, we see that all 3 of these are now chasing the player. But what happens when we hit play is that they no longer collide directly with the player, but really they're going to the spots right around the player. And you might see this type of thing in standard combat, right? You're playing a game where it has a melee enemy, they sort of dash in and out of combat. This is one of the reasons I like to leave auto braking off, because watch what happens when I turn on auto braking. They go to their spot and they just stay there. And this is okay, right? If we have a fluid animation and you have really high quality animations, this is totally fine. When I move the player, Oops, that is not the direction I thought I was moving it. When I move the player, they'll all follow to the exact spot. But if I turn off auto braking, they'll sort of go in and out when I move the player. Right, they're moving in and out and reacting dynamically to how the player's moving. So as a player, we're moving in and out doing this combat sequence. All of these AI aren't colliding with each other. They're moving as a unit, right? As soon as we get out of range, they start patrolling. If we get into range of a single one, they all attack as a unit, but they're not colliding with each other. They move dynamically in and out of this combat system. And that's exactly what we might want from an AI. That seems like a fairly intelligent AI. They divide, they conquer together, and as soon as they're gone, we move away, they go back to patrolling. So that's the implementation that we set up for this week. Next week, we're going to talk about editing this waypoint system. So let's say we want to have our AI be a little bit smarter about where they see you. If they see you in a single location, well, let's add that location to the waypoint system, right? Let's have that be a position where we patrol. Next week, we'll set that up. Should be pretty easy, pretty exciting, and then maybe we'll move on to some race AI and some other common applications of AI in video games. So I'll take this time to say, if this video helped you at all, please remember to like, comment, subscribe. If you have any questions, let us know down below in the comments. In the description, you can find a link to our Discord. We're always more than happy to help you there, or you can just join and say hi. We'd love to see examples of what you're working on. If you throw this AI into a project, go ahead, join the Discord, let me know. I'd love to see it. I'd love to play your game. I love playing games as much as I like making them. Be sure to look at our Twitch. We have a company Twitch. You can give that a follow. The link is in the description. As always, I hope this helped. Like, comment, subscribe, all that jazz. We'll see you next week.